So let's see more in details these four and different kind of loops that we can use to repeat interactions. We already saw several times the for loop. Just here to say that you can have several inner loop in one command here. So we have two index I and j, and you can notice here that it is run first the I, and then as an inner loop is run the j loop. This is a range from 3 to 4 and is from 1 to 2. Then the while blocks are similar. You write while and the condition that you want, for example, while a equal to 10, and you can have infinite loops like here, writing while true, or you have to put some conditions. And here the condition is that we start with 1, we increase of 1, and when is equal to 10, with this keyword break, we go out from the loop. And the continue is another keyword that just means that the loop arrive here. Continue will not continue with the rest of the loop, but will go back and will make another iteration. So you go here, continue, continue, continue. So this will never be run, as you can see here, where it arrive till 10 and then it stop. Sometimes you want to write in a more concise way a for loop. You can use list comprehension as I wrote it here. We already saw, I think, this one. So here you write within squared brackets, and here you have what you want to do. And here again you have a for loop under different condition, and you can also put some conditional statements all in one go. So here, as you can see, that I run only when j is higher or equal to 4 and then the loop is on this I. Finally, another possible way to have multiple statements and repeated iterations is to use the maps function. And the map function apply a certain function, possibly an anonymous function, as in this case, to a list of arguments. So here I have two arrays, and the map function will take one from each argument and as parameter, and pass them as parameter to the function here. This is just a println, so here it does what you expect to do. So it can be used to make, for example, broadcasting, but is more flexible. And put attention to not confuse this arrow with one single line that is used as anonymous functions, with double line arrows that are used to define a pair object, for example, in a dictionary. Let's now see the conditional statements, like if blocks. We already said several times. So we can write an if block like this, if, else if, and then a set of different else if, and then finally a condition if no one of this condition is true, what to do. And in the condition we can specify logical operators like not, and or, and we can write here. So here is another if, very simple, without else if, and you can do you can write this simple if statement in a more concise way by using the so-called ternary operator. And you can see here how is made. This syntax with this question mark and the two dots here, it say b equal if a is lower than 5, b is equal to 100, otherwise is equal to 200. Now the same things here, it can be written in even more conscious way using so-called short circuit evaluations. What is this strange name? It is the mechanism that programming languages, not only Julia, employ when they are in a situation where there are conditional statements with different logical applied, and they are in a situation where the specific value that they got is enough to resolve the conditional statement, whatever are the rest of the conditions. So for example, is here I write b equal to 100 and a, now I forgot what is a is 10. You can see here the condition is a minus 5 or b equal 200. You can see that the second part here must be executed, because when it does this a minus 5 and then there is an or, the program doesn't know yet if this will be this will change to true or it remain false as it is here. It needed to evaluate these things, this syntax here, this statement here, in order to arrive to a response of this or logic. So I'm running this one, and b has been changed to 200 because this was not enough. But if I'm writing here, so a, we said that is equal to 10, okay? And if I type a minus 50, this is already true. So why should I bother to continue to evaluate other things? Let's short circuit the matter here and say, because this one is already true, and I have a or condition, I don't need to care whatever this one is already true. So if I run this one, this b equal to 500 will not be even considered, and my b will remain to 200. So this using or the same using and can be employed in place of using an if statement. And put attention to not confuse the Boolean operators that we just saw with their analogous that bitwise operators. And you can see, for example, a equal to 3 and b is equal to 2, and this is their bit string representation. So when I use the bit string operator and I make an AND at the level of the bits, I have a 2 because I have only 1, and this is a 0. While if I do or at the level of the bit, I have 3 because I take wherever it is 1, so I will end up with 1 and 1 at the level of the bit.